Before we crack on, let us invite you to join our beautiful, amazing Wi-Fi day that happens on September 19th. It's a massive event, probably the biggest event online when it comes to the Wi-Fi networks, full of amazing speakers. Unfortunately, I won't be there, but Matt and the team will be there. I won't be there because I'm becoming a dad for the second time. So apologies for missing this amazing great event. There is a QR code. You can scan it, you can register, and you can join us on that amazing Wi-Fi day.
It's only you that thinks it's unfortunate that you can't join us for Wi-Fi Day, Mac. Okay. Well, thank you everybody for joining us on today's Ekahau webinar series. It's so great to see so many of you returning back and a lot of new faces. Today, we are going to be talking about how we can design for complex wireless environments. And we're really lucky because we've got some real great experts in the field joining us to share their experience and expertise with us on how we can overcome such challenges. So Mac, why don't you do a quick round of introductions?
Totally. So we are Matt and Mac. So we want to introduce ourselves. We are Ekahau team, joined with Dale and Stu, Ekahau team, ECSC and product marketing, and as is also Stu has changed a little bit. So now he's looking at all the communities and feedbacks and all the other very important stuff. But the stars of the show today is Rob and Steve, both working for Juniper Mist, amazing Wi-Fi engineers, great friends of ours. So thank you very much, guys, for joining. Rob, Steve, how are you doing? Let's start with Steve.
Yeah, great to be here. Thanks for having us, and looking forward to all the exciting conversations we're having today.
Likewise. Robert, how are you doing, my friend?
I'm doing good. This is good. I took a flight home early just to make sure I could be here.
You did?
Yeah, it's nice.
Where did you fly from?
I was in London yesterday.
Where? In London, but the wrong London.
No, the UK London, not the US London.
UK London. Okay, gotcha. Cool, guys. Thank you very much for donating your time. And let's crack on with the amazing content, shall we?
All right, so I guess I'll start off here with kind of the concept of this is best practices and kind of gathering what you do before you even start looking at designing anything. If you've watched any Wi-Fi webinar anywhere in the world, I'm sure you started off with defining requirements. When we start doing complex designs, and they're not typical office buildings, they're not just basic cubes, and you have to start doing things with external antennas, and you have very fine applications, requirements are huge. You need to start and go and deeply understand not just what devices you're using, but what kind of outcomes that need to come from those devices. So is number one and always will be number nine is understanding your requirements, and then understanding your environment. I don't know how many times I've been handed, today we're going to be looking at warehouses. I've been handed a warehouse floor plan, and it turns out that I'm missing half aisles, or they decided to change the aisles around one point in time, or just the entire warehouse has changed because the way they decided to do things. So you go off, and if you wouldn't have understood that environment, you would have did a design and walked in and been like, oh, that doesn't work. The neighborhood, you need to know what's going on around you. It's one of those things where you have to be cognizant of what's happening outside. Like if you're out in a dock or a port somewhere and you're dealing with DFS and radar, these are things that you have to know about before you walk around. And then, as always, cover what you want. If you are, this is especially when we're using external antennas. If I'm going to start using high gain antennas, I don't want to be blasting my neighbors. I want to hit where I need to go. So basically, always put your Wi-Fi where your people are, or where your devices are, or where it's needed. And then configuration. As we all say, I love AI and ML. Cooper and I are basically, we work for, Mr. AI and ML. You still don't do defaults. You always put in controls, you always put in settings, you always make sure that you take and adjust based on what you need. I like to call it, you put in boundaries. We want you to do what it does, but you still need to have your upper and lower boundaries.
I think that's a good point, Rob. The last one is, know what you're working with. I know some people are working with the same vendors and infrastructure day in and day out, but, a lot of VARs and integrators out there might be deploying something new for the first time. So, that's where it's really important to know the tools and know the systems that you're deploying with and what their benefits and or limitations are, and how that's going to impact your design and your deployment.
100%.
Cool. Yeah, segue to talking about antennas. So as Rob mentioned, designing for complex Wi-Fi doesn't necessarily dictate that you're going to be working with external antennas. It's just, the example that we've chosen to focus on here, because it's usually something outside of the realm of normal that a lot of us are used to working with. As Rob mentioned, we might be used to deploying Wi-Fi in offices or maybe schools. Maybe auditoriums and lecture theaters might be as complicated as you get, but once you start getting into manufacturing, logistics, warehouses, even stadiums, external Wi-Fi for parks and municipality areas, that's where we start to see more of these use cases come in. And so the antenna rules are really important, even when you're considering the radiation patterns of internal antenna access points and what is out there today. So as Rob mentioned, we want to cover what we do want, as in where we want to provide coverage for our clients to connect, and making sure that we're not covering what we don't want, as in we want to make sure that we are maximizing the use of the spectrum where possible, making sure we have maximal channel reuse across the plan, which also factors into channel widths as well, which we'll probably talk a bit more about later, but also minimizing co-channel interference and also working around any interference we get from our neighbors, as Rob mentioned. So this is a nice little, graphical overview that the Ekahau team have come up with, which basically gives an analogy of when you're talking about lighting up a space. If we think about lights and light bulbs and different light shades that you can have to direct light where you want it to go, it's a very good analogy if this is the first time you're considering outside of the norm of dealing with omnidirectional antennas or internal antenna Wi-Fi access points, is considering, where are you trying to direct your coverage? Well, think of a spotlight in a stadium. If a single spotlight was on, where are you trying to provide coverage of that light into a specific sports field or even the crowd? And you can start to get an understanding of, we need to apply a similar methodology when we're designing for Wi-Fi too. So you can see the guy on the right-hand side there, he's got the best directional coverage just for his area, and we're not covering anything else. We're not covering what we don't want because there's nobody else in this particular area that we need to consider. So this should hopefully help you start to understand why we have different antenna patterns when we're designing for wireless and what the different use cases might be for when we do that.
So before you go on, I just wanted to make a quick comment on that last slide.
Yeah.
If you ever have to give an explanation of antennas, this is beautiful. Always use this slide. Just take a screenshot of this lower thing and just use it. Copy theirs. Yeah. It's a lovely little slide. I just really like it. So sorry.
It's really good, especially if you're working with site foremen and people in manufacturing facilities that are keen to understand. A lot of people are generally curious. They're really keen to understand why do we need to do things a certain way. As Rob mentioned, this is a fantastic way to help convey that message.
People might not understand RF, but they definitely can understand the difference between a light bulb and a flashlight.
Exactly. So just a little bit of RF theory when we're talking about antennas, and some of you might be familiar with this, especially if you've done Ekahau ECSE or CWNA or any other vendor certifications typically cover this sort of fundamental concepts. But really, when we're talking about antenna radiation patterns and antenna gains, whether it's internal or external antennas, everything is in reference to what we call an isotropic radiator, and that is essentially an ideal radiator analogous to the sun. So 360 degrees in both horizontal and vertical planes. Think of it as a perfect sphere. But this antenna does not exist. It's just physically impossible to manufacture or produce it. But this is what we're referencing when we actually look at antenna radiation patterns. And when we're talking about, beam width, and when we're talking about, antenna gain and things like that, is in relation to this isotropic radiator antenna. So you can see some great examples here where we've got external antennas. The first one is what we would call a dipole, which is actually an omnidirectional antenna. Even though it looks like a stick, a lot of people confuse this in thinking, and you've probably seen some examples of bad fire where these antennas get deployed in the environments and people are pointing the dipoles in the direction they think that the radiation pattern happens, and they're completely, unfortunately, incorrect. When you're looking at this radiation pattern here, we need to think of sort of a round donut shape around the pole of this, as opposed to shooting out the tip of the end there. So, it's not like a pointy lightsaber like Stu had in his background. We're talking about a donut shape, and that's what is essentially in most of our internal antenna access points that we use as well, is something similar to that radiation pattern. Then we go into slightly more directional external antennas, and this is where we start to see different beam widths, and we see a lot more directionality in the radiation pattern. And you can see where, compared to the isotropic radiator, it's a complete different pattern that we've got there. And so there's a lot of engineering that goes into designing these patterns, and there's going to be different elements of gain that you can get there as well. And as we step down to the last one, this is where it's a highly directional, high gain antenna. And you might have seen some similar videos out there on the internet, or similar presentations, where when we talk about even this donut shape, the higher the gain is, you actually start to squish that donut smaller on the omnidirectional antenna. The same thing happens with high gain antennas, because the radiation pattern is designed to focus energy in one direction. The higher the gain is, the more narrow that beam width becomes in terms of directing that energy towards clients. So it's also very important to keep in mind when you are doing designs. It's something that's mentioned as a best practice across the industry, as well as in Ekahau ECSE trainings, that you don't necessarily want to design for green everywhere or transmit power on full everywhere. We need to be very mindful of providing the coverage where we need to, but also being conscious of the uplink connection from clients as well back to these access points and antennas.
It's not always good.
Hey, Stephen, gents, when I see that picture there, you know what I see to memorize that for its test? I see warp core, I see Goodyear blimp, and I see a Zeppelin.
Yeah, that's a great way to look at it. Great way to look at it.
That's nice.
Yeah, it's awesome, Stu.
So we picked a warehouse as a bit of an analogy for one of the complex designs that we're going to be talking about today. And in this example here, when we look at this warehouse, we can see there's a few different types of spaces. We've got a typical kind of office space inside. We've got some pallets that you would probably stack up with inventory. And then we've got some racking aisles, as well as an outdoor space where people park their cars and lorries drop off and collect shipments. So when you're typically designing for an environment like this, you would probably use a mixture of different types of access points. In the office space, APs with integrated omnidirectional antennas would probably be okay. Over the pallets, you might shoot from the top or shoot from the side with maybe like around a 6, 7, or maybe even like an 8 dBi gain external antenna to cover the pallet areas. And then in the racking areas, you'd probably use, I don't know, excuse me, an antenna that has potentially 10, 11, 12, 13 dBi gain, and you'd maybe shoot from the side or from the top to cover the racks. And then outdoors, you'd want to use an outdoor access point to be able to provide that connectivity and coverage outside. But we kind of had a couple of questions when it comes to, designing for 6 gigahertz. As of right now, can we use external antennas with 6 gigahertz? How about outdoors? Is it different for the EU, or is it different versus the US? So we thought this would be a great conversation starter. But before we pass this over to Rob and Stephen to discuss this and how Juniper Mist approach this and what we can and can't do as of right now, we just want to make sure that everybody on the webinar is on the same page when it comes to 6 gigahertz, because you may or may not be familiar with the 6 gigahertz frequency band and the additional channels and the frequency band that we've got access to recently. So if you're based in the US, it's fantastic because you get an additional 1.2 gigahertz of spectrum that you can use and leverage. So that would actually equate to something like 59 more non-overlapping 20 megahertz wide channels, which is fantastic because it gives us a lot more space to use for our access points and our radios of our access points and the client devices to be able to connect. However, if you're based over in the EU, like quite a lot of us on the call presenting today, we don't get quite the same amount of access to the 6 gigahertz spectrum. We get about 500 megahertz, which translates into 24 non-overlapping 20 megahertz wide channels. Still fantastic. It means we've got that extra frequency band, that other lane on the motorway we can drive down, start shifting our client devices to 6 gigahertz, which in turn will benefit our older devices on 2.4 and 5 gigahertz. But with 6 gigahertz, there's a few things we have to think about, especially with getting devices onto the 6 gigahertz frequency band, scanning the channels. But there's also something else called device classification, which I'll hand over to Mac to explain at a high level for, because that's going to become very important when we talk about the complex environments.
Exactly. So it's no longer the situation where we have just 5 gigahertz capable device and 5 gigahertz capable access point talking the same generation of Wi-Fi. Now in 6 gigahertz, we have more device classes and access points classes, and they have different limitations. Just to shout a few limitations: a lower LPI, a low power indoor. These are the access points and clients that only can operate inside. They cannot be operated using the battery. You cannot use external antennas. They must be built in, and you have power limitations. And most of the access points today, they are LPI APs. Now, you can't operate them outside. So today, pretty much from the practical perspective, you really cannot have 6 gigahertz outside. Well, you can, we get there, but it's quite complicated. This gets us to the standard power, SP APs. Now, in order to operate standard power APs and standard power clients, we have to talk to the database. We'll talk about it in the next slide. Like this one, AFC. AFC provider is a central place that looks at available frequencies in different geographical areas. We are trying to protect existing 6 gigahertz technologies, so we don't overlap with them, we don't interfere with them by using our Wi-Fi, especially outside. But our access points now, SPAPs, they have to be able to locate themselves in order to provide the information about the location, their height, their antenna, their gain, to the AFC provider. And then AFC provider comes back to the access point saying, Mr. AP, you can use that channels and you can use that power levels, you can't use anything else. Now, AFC, we already have that available in states. We have more and more AP vendors having SPAPs in their portfolio, obviously including Juniper Mist. And now in Europe, it's a little bit, we're a little bit behind on that pain. It's pain. It's like we are like what, 2 years behind in the EU. So we should have access to the AFC like what, next year, probably 2026 even. So we don't know. And then we have the very low power VLP APs and VLP clients with a very big or considerable power restrictions. We will be able to operate it outside. We can do it in Europe. In States, we probably cannot. It changes all the time, so keep an eye on it.
So that brings us...
just while you're talking about AFC, is something that a lot of people haven't considered when they're talking about, preparing to design for 6 gigahertz, which we'll touch more on from the RF and the requirements standpoint throughout this webinar. But is when you're talking about AFC, and Mac mentioned, the access points need to know where they are. That requires some sort of location information, but it also requires checking in with an AFC provider. That means outdoor access points or standard power access points need some way of communicating to an AFC provider, either natively through the internet, through a cloud managed platform, or through some sort of proxy that can then send that information to and from the infrastructure and the AFC provider. So it's something that a lot of people sort of get caught out with once it gets to the final stages of deploying and thinking about this. All your Wi-Fi design might be fantastic, but it comes down to what I mentioned earlier about knowing the system that you're deploying and the requirements around the infrastructure that you're deploying and how that would then connect into the rest of the network and those sorts of requirements around network connectivity beyond how beautiful your 6 gigahertz Wi-Fi design might be.
Great point there. And that brings us back to this warehouse discussion, because the majority of access points that have been available in the past when 6 gigahertz come out was the low power indoor access point. So Stephen or Rob, I don't know who wants to take this and talk about how you would approach this from a Juniper Mist perspective. Obviously, with the racking areas and the pallets, you'd probably want to leverage directional antennas and then outdoor APs to cover the outdoor space. So what is the kind of like recommendation or the approach that we take right now?
Well, first you would want to gather your requirements, because you want to understand how this warehouse is being used. Because I've gone to the point where, see these trucks right here? These are nice, big, generally metal boxes. They take their scan guns in there and go all the way to the back, and they need to scan in there. So they need Wi-Fi coverage inside of that truck bed. So you have to understand, are they scanning inside the truck, or are they just offloading and scanning outside of the truck? That's an actual thing that has come and given us great headache. Or if you look at these little lifts, are they going up and scanning up? Are they pulling down and scanning down? So do you need to be able to have access 2 meters up and 1 meter down? So it's just a lot of things that you start looking at and trying to understand and approach. Generally, our philosophy on design would be we would do APs in the aisles pointed down, because what this does is it actually negates the biggest problem with warehouses is the racking. So everybody, because when you come to a warehouse rack, when it's empty, it's lovely. You could use Omnis everywhere. If it's full of cardboard, might not be a big issue. Might be a huge issue. You've got glass, you've got water, you've got whatever else could be there. By running those APs in the aisles and facing them down, you completely negate the fact that you need to worry about what's in those aisles. And then with using the directionals, you're already starting to control where you want that RF. So when those are empty, you're not getting the problem of, oh crap, it's empty. Now it's going to flood everywhere.
Yeah, and I agree exactly with what Rob said. And one of the attendees actually put a great question in about, especially the example we're talking about with a warehouse, what is in those pallets? What's on those racks? And that's exactly what Rob was saying earlier. You need to know your environment. You need to know exactly what's in there. You need to know how it changes, because I've done designs for warehouses, that are massive and they're big distribution centers. But every 6 months or so, they decide to change the layout of the racking and everything like that, which is going to factor into exactly where you can put your access points for a certain amount of time, or consider that you might have to be designing for a changing environment. But also another one of the questions from one of the attendees was around ceiling heights, or actually access point installation height too. So this is where, we don't want to get into too much of a, use the trademark, it depends, but it really does depend, because there can be a scenario where you have a warehouse, depending on the materials in the racks and in the produce there in the aisles, and depending on the height, you could actually use internal antenna omnidirectional APs. And that's a trade-off between the coverage, the connectivity, the capacity, co-channel interference, and also time, effort, and cost to install.
Also around the devices, if you only have 4 or 5 devices running around a warehouse, do we need to spend on 2 APs per aisle on redundant coverage? Is the difference of, is this warehouse, if an AP goes down, are you losing thousands of dollars, hundreds of thousands of dollars, or it's not a big deal? So, these are all comes down to those requirements, is because to do a warehouse right is not cheap. But then again, a warehouse done right doesn't always is a scaling kind of a metric, because it depends on what you need to do. Like, I've seen warehouses where they have done a full 2 APs per aisle, need 100% redundancy, and they have 14 devices. So they have 3 to 4 APs per person.
Let me just add one thing to that discussion. Rob, this are very good points, extremely good points, especially with the number of the devices and what these devices do in the network. There is one very important thing to understand that people are asking us all the time, like, what do I do where I have all these access points on both sides of the aisles, for example, and I need to have redundancy, I need to have everything, but my materials change. That's another question from the chat. What happens if my materials change on the racks? And you will be in a situation where in open space warehouse, where you have racks that are close to empty, you will have a CCI, so it's cross-channel interference, channel contention, radios operating on the same channel. It's just same things, different names. You will see a CCI of, I don't know, 10, 20, 30, even 40. So we've done a warehouse with Matthew where when it was empty, we had a CCI of 35, for example. When it wasn't empty, we had a CCI of 3 or 4. So that changes a lot when it comes to the CCI, but is it really a real problem? That's the question that we want to answer. If you have just barcode scanners and your Wi-Fi is not very actively used, there is no hammering the Wi-Fi with heavy traffic, then the CCI really in a correctly configured Wi-Fi network where you have minimum basic rates that are decent, like at least 12 megs, where you have decent coverage, where you have 1 SSID or 2 or 3 SSIDs, then CCI is not a real problem. However,
or
if you have
ensure that your scanners are actually configured for 5 gigahertz and not 2.4, those are always a good one.
Exactly.
Yeah. So to answer the question about the racks, that's where when we're designing, we use an antenna from Exceltex. I have one down here I can show if people really want to see the 6 gigahertz one when we get into that conversation. That's got more of a north-south polarity, so it works down, shoots down the aisles. So what you're doing is you're taking the racking out of the equation. You're essentially focusing on putting Wi-Fi in the aisle, because you'll never need Wi-Fi. Well, I've never ran into a use case, I'll never say you'll never need it, where you need Wi-Fi in the racking. So what you're doing when you're having that is, one, you're using a directional antenna that's basically projecting RF down the aisle. It does have some bleed, obviously, that's impossible to not have bleed through the racking, but you're doing it down the aisle way, so that way you're focusing on that aisle, so the racking doesn't matter anymore. And to your point, you'll get some CCI when you have an empty rack, but it's not as bad as if you were having an Omni, or building to building a design based around saying having a full loaded rack, and then when it goes empty, you can hear that AP from across your 1,000,000 square foot warehouse. So yeah.
So we have a demo prepared to walk and talk through with everybody on the webinar. But before we do that, we actually have a couple of poll questions that we're gonna just quickly launch and discuss. So Mac, maybe you can read it out whilst I
Totally.
get it going.
So we ask this question quite frequently, so we want to see what's changed. The question is, have you upgraded to 6 gigahertz? It can be Wi-Fi 6E or Wi-Fi 7. We know people with Wi-Fi 7 already. And the answers are yes, no, but planning in the next 3 years, or sorry, 3 months, and no, but planning in the next year, and no current plans to upgrade for some reason.
Yeah, this will be interesting to see because, yeah, like Max said, we have asked this question a few times before over the last couple of years to see where, just to kind of like gauge where the community is at with upgrading to 6 gigahertz and what your thoughts are on that and what the current kind of like state is and the plan. So we'll just give it a few more seconds to give all attendees a chance to cast their vote. And then what we'll do is we'll end the poll and then share the results with you as well and discuss for a few moments.
And just for some that we've seen in Juniper Mist is we've seen about a 20 to 30% adoption rate of 6 gigahertz in some large environments that have been deploying it already. So, you know, it's a mix of environments, whether you're talking about higher education, universities, or even corporate offices. And I think one of the other big topics that we probably won't be touching on too much here is around security and WPA3, you know, being mandatory for 6 gigahertz usage too, which also plays a big part in 6 gigahertz adoption beyond the RF design and client support and things like that. So definitely something else to keep in mind when you think about requirements for the network and design. But yeah, we've seen quite a big uptake, and the same with you know, even WPA3. Enabling WPA3 enterprise has been pretty easy. You know, doing pre-share key or SAE has been, you know, mildly successful with a lot of people doing transition modes. And then, you know, enhanced open or OWE can be a bit of a mixed bag depending on the clients. But, you know, we've also got some great references on our website around designing for 6E and 6 gigahertz, and that includes some considerations around WPA3. So I might pop up a chat about that because it's a very useful website to go through.
I would just add extra resource from Juniper Mist team from Wes Purvis. Every WLPC, every year he presents the real statistics from Mist, and there are like millions of clients, and the statistics, they are mind-blowing. It's amazing to see how many clients are capable of 5 versus 6, how many of them are 6E versus Wi-Fi 7. It's amazing. So go and search on Google for WLPC Wes Purvis presentations. They are amazing. Every year we have stats from him.
Perfect. Okay, we've got one more poll question to quickly ask. So let me.
Okay, and the question is your environment Wi-Fi first? That means if you do have docking stations or not, do you use cables or not? No cables, no docking stations, it's a wireless first environment. And the answers are yes, we prioritize Wi-Fi for most connections. B, yes, but we still use wired connections in some areas. C, no, we prefer wired connections. And D, no, Wi-Fi is supplementary.
Not sure I can agree with anybody on that last answer anymore now. Wi-Fi is life.
Yeah. I like this question, but it causes me to want to hop on a soapbox.
Well, we're not here on an Ekahau wired design webinar, are we?
Yeah, no. I was gonna be like, yes, Wi-Fi first I'd be interested to hear what people's Wi-Fi first is. I'm a big believer of, if it doesn't move, wire it. And then Wi-Fi first or Wi-Fi only office means your users are wireless, not your cameras, not your printers, not your telephones. Because I've seen people go out and buy 2-4 telephones for their desks.
That's smart.
Yeah. So yes, intelligent Wi-Fi everywhere is awesome.
Yeah. So fortunately, a big percentage of the webinar audience does agree how important Wi-Fi is and wireless first environments. Yes, some might still have some cables, but a big percentage do agree about prioritizing Wi-Fi for most devices. And I'm sure
70+% of people think that they are like close to wireless first. But guys, let me tell you that with the addition of 6 gigahertz, doing wireless first has become practical and not too expensive. Previously, with just 2.4 and 5 in very heavy environments, like tons of density, tons of clients doing tons of things, wireless voice clients on your phones and stuff like that, like constantly video conferences everywhere. It was very challenging. We had to use directional antennas shooting from the top, tons of radios, reuse the frequency in a very smart way. And now it's as simple as just doing a high density omnidirectional design in most open spaces offices with tri-band radios and tons of clients being capable of doing 6 gigahertz. The capacity is there. It's just there. So yeah, especially in States.
I find it interesting that it is much easier from a Wi-Fi perspective now. I think that's a lot harder from a planning perspective because now you need clients, you need security to be looked at again. It was like when we usually go from like a Wi-Fi 5 to a 6 or 4 to a 5, it was the RF changed a little, the protocol changed a little. You might have needed a new device, but with this adding a spectrum and security, it's like completely changing, I think, people's viewpoint on how they can do it because now they have to go to WPA3. And then OWE, it's like I wish OWE, I think, was one of the best things to come out of the standard because of what it does, and it's probably one of the least used features outside of MU-MIMO.
MU-MIMO.
Oh, Mac, let's jump into the demo that we've got. So I'll stop sharing so you can take over.
Okay, let me share my screen, and there we go. You should see my screen now. So this is the Wi-Fi design made by the boys, by Rob and Steven. So I'm running it because I have the best connection because I'm not sitting on a cable, I'm sitting on a Wi-Fi, leading by example. So guys, let's talk through. What I have here, I have the 5 gigahertz design. And as we've discussed before, I've updated the design to 6 gigahertz as well, using the antennas and access points that we've discussed. So we have both options. Guys, I will be I'm your PA.
Yeah. So could you do me a favor, Mac, and then just select one of those APs in the aisleway, just at once. We just see the RF for that. So when we were talking about designing for the aisleway, this is what that antenna does. So as you can see, we are looking to just put it where it goes. So that way the racking, it really takes the racking out of the equation. This right here is definitely designed for high density. This is basically 2 AP coverage. I've seen this go from, you could probably dump this down to, I think there's 4 APs per aisle, or 2 or 3 AP. Yeah, you could probably dump this down to 2, almost even 1 AP if you wanted to be real cheap about it. I wouldn't recommend it, but again, money versus value is the whole different conversation. Oh, don't ever put it there. No.
This particular environment,
you're supposed to be my clicker, not your own clicker.
environment was
yes, and what this does is it takes advantage of the aisles. Is really what this design does. Is and in a perfect scenario, this is how I would design it. And if you scroll out, zoom out a little bit so we can see some of the omnis. So the white ones are omnis, and these are actually put in to cover those transitional spaces, and they work really well. I think somebody was asking about the mixing of antennas and omnis, and does it cause any issues? You get a very nice kind of transition. You're essentially using the metal and the racking in there to help kind of move things around. So I would say they usually about 1 AP every 100 feet for the omnis, because you don't really need a whole lot. They're low power. The omnis over here, if you see down in the bottom, if you scroll down right there, like right there, those are meant for getting to the back of the trucks. As you can see, they're there so that way they can get back there. And then you also have outdoor APs that help. The nice thing about outdoor APs like this, it's usually when you need Wi-Fi outdoors, it's those trucks. So you'll have the trucks coming in to basically start their communication. It's very low bandwidth, very low need. Latency isn't really an issue. So you're able to push the boundary. You don't need super high MCS rates. So you can actually get like a neg 70, neg 75 out there, and it's fine because it's not for actually usable. It's just for trucks to say, hey, I'm here. So you get a lot.
Sorry to interrupt you there, Rob. Before, I think Mac is about to jump to the next kind of like design phase that he's got prepared there. But one of the big questions we had is like, what can we do as of right now with designing for 6 gigahertz with these outdoor spaces, and then with these access points and antennas in the middle of the racks, leveraging the Axotex antennas. Like maybe you can just talk us through this section of the design here.
So today in the US, you can deploy the 45Es with antennas. 6 gigahertz will be disabled because it hasn't been allowed in the US yet. Most of the rest of the world, you can actually enable 6 gigahertz. There will probably be some countries that's not the case, but I know here, most of the places in Europe here, you're able to use indoor external antennas with 6 gigahertz. Same with the outdoor, same outdoor right now. I don't think anybody is allowing outdoor 6 gigahertz yet. But you would deploy your 6 gigahertz capable outdoor AP and you just would have 6 gigahertz on not enabled. So you design for it, but you just don't enable that band yet.
Yes, Mac, if you flip to 6 gigahertz, because I think you're on the band selection. So basically you can still design for 6 gigahertz for the indoor spaces and for the outdoor spaces as of right now, but it's just might be the case temporarily. You have to have these radios disabled until we're at a point where we can enable them. Is that right?
Yes.
So that's what you've highlighted there, Mac, is those outdoor access points. So you can plan and design for these APs as of today and have like the 6 gigahertz coverage. However, for the time being, they will just have to probably be shipped with their radios disabled until a point where we can, leverage AFC or standard power stuff or whatever, and then be able to enable them. But you can still plan and design for it as of right now.
Yeah.
That's correct. So guys, in case that you wonder what APs we used, for 6 gigahertz, we have outside AP64. Outside is AP64 with built-in antennas, okay? So these are, I guess, mounted to a pole and they are shooting down, right? So they are like 6 meters above the ground and they are shooting down, covering it very, very nicely. So when you have people or devices like walking or driving around the parking lot, they will be roaming between the APs. The capacity is there, lovely coverage pattern, outdoorsy, and you don't need to have any enclosures or anything else really. You just put an access point there and run a cable to it. Inside the directional APs, we have, like, let me show you the coverage pattern from these access points. So these APs, they have, look at that. I will show you a visualization, 3D visualization in a second. The elevation pattern, elevation is a vertical pattern. It's very narrow, but the horizontal, the azimuth, is very wide. And that means that they are covering entire aisle, pretty much ignoring what is in that aisle, as Rob has mentioned. This is absolutely fantastic. So look at that quickly. So for the Ekahau AI Pro warehouse example, we obviously, this is a greenfield design, so there was no survey done. We had to do, or the boys, they had to put all the attenuation areas, racks, measure the attenuation or assume the attenuation, put the walls in, and create an environment to then put access points in. But now what we are looking at here is a different warehouse where we've done a survey. We have located automatically the access points by walking around, and this is just it. That's the survey data. We haven't put any walls, any racks, anything in it. And now we're just using the same APs, the AP45Es. I'm using a different antenna with 30 dBi again, but this is a similar antenna. Look at this pattern. This is azimuth, it's very narrow, and then the elevation is very wide. So we are also covering entire rack shooting from the top like that, okay? Shooting from the top like that. So when you look at that AP, like now I'm in this aisle, when I move it to this aisle, it covers that aisle as well. And again, the fun fact here is we haven't done any walls, any attenuation areas, nothing. It's just designing based on a survey data. And that is it when it comes to the warehouse quick review. If you have any questions, put them in Q&A. We will have some time towards the end shortly to answer those questions for you.
Yep. So Mac, maybe you can jump back to the slides now and we can talk about all things wireless. So not just wireless, maybe even BLE, right, Stephen?
Yeah, for sure. I just wanted to mention one thing before we did that, because a lot of the questions that I see coming through, not in just the chat, but also the Q&A, was around what Rob was mentioning first off, around gathering requirements. So, Rob's mentioned in there about using some of the built-in attenuation area values for warehouses if measurements aren't taken. A lot of these environments can benefit from doing AP on a stick surveys or even attenuation measurements with your Sidekick and some other antennas. or access points to actually measure what the actual attenuation loss is. And the same goes for, you know, a full rack versus a half full rack versus an empty rack to help feed that into your design. And then, you know, we're talking about the predictive design stage here with these examples that Mac was showing. And, you know, you obviously want to follow that up with a validation survey afterwards. So, you know, that's how you sort of validate that this design worked and met the requirements that you fed into this design and learnt about all of that cool stuff. So I think one last point around 6 gigahertz that I mentioned, and, you know, Matt touched on this briefly, was different channels, different regulatory, you know, requirements for the different regions, you know, FCC in the US versus the rest of the world. Power spectral density, if you're not familiar with that, is something to definitely read up on, because that's usually the biggest consideration when it comes to moving to a 6 gigahertz design. So part of what Mac was showing was just saying, look, we've taken a Wi-Fi 6 2.4 and 5 design. How easily could we just replace that with 6 gigahertz capable APs? And do we need any other additional APs in there? And from the coverage perspective of downlink from the AP to the client, no, we don't. But if you're in the US and you're limited by your uplink power spectral density, your clients might not be able to transmit as strong as they were able to in 5 gigahertz based on that design. And so some guidance that we've seen is, you know, some average RFSI differences in some environments in the US is clients, we might be sending upstream RSSI received by the access points as negative 55 dBm, but then 6 gigahertz, we might be receiving at the AP at negative 64 dBm. That's quite a big difference. Whereas downlink to the AP, to the client from the AP, should I say, might look no different. And I know, Matt and Mac, you've got some examples of surveying with a sidekick. So the downlink is fine. You've actually been able to get away with direct replacements from the downlink coverage perspective. So definitely keep that in mind when designing for 6 gigahertz migrations. Cool. All right, let's talk about location. Bluetooth, big segue there. So now we're going all the way back to 2.4 gigahertz. Fun. So the reason why we wanted to bring this up is because location is actually very complicated to design for as well if you don't have the right use case in mind. But the same practices that Rob mentioned early on with those opening slides apply. You need to gather the requirements, the use case, the devices, what is the expected accuracy and experience with this. And you know, is the use case in a downstream direction, such as wayfinding on a device, or is it upstream with tracking assets? All those sorts of things need to come into your design for gathering requirements. What we're looking at here is something unique that we've done at Juniper Mist in terms of Bluetooth location. It was actually built in some directional antennas into you know, some of the you know, best-in-class access points we have, like the AP43 and the AP45, which is this directional 16-element Bluetooth antenna array, which actually sends out Bluetooth signals in you know, different directions, 8 different directions essentially, and also receives you know, in 8 different directions too. And it's at a 45-degree angle as well down from the access point. So what does this mean? It essentially means that when you're actually doing a Bluetooth-based location design, because we built this into the Wi-Fi access point, you typically don't need a large uplift in infrastructure, or sometimes no uplift in infrastructure or additional APs when it comes to a high accuracy indoor location use case, because typically we can get about 1 to 3 meters for use cases such as wayfinding. So thinking about, you know, finding your way through a campus or through a hospital or a building using a smartphone app, or even with asset tracking, 3 to 5 meters accuracy from this sort of deployment. But there is the option to add supplementary Bluetooth access points in there called BT11s, which I think Matt will walk through a bit later. But you know, there's all sorts of IoT use cases coming out these days, not just Bluetooth. So it's not just about location. You might be designing for some other automation or IoT use cases as well. And you know, as Wi-Fi generations go on, these access points are coming with more and more features built in too. So you know, Bluetooth with the directional Bluetooth VBLE array that we have is one use case. And these are some of the benefits that you know, Matt's showing here on the screen here is asset visibility, tracking high value assets in a warehouse that don't necessarily need something highly complex or more expensive than what Bluetooth provides. So it's very cost efficient. Wayfinding, you know, most people have a smartphone these days. Most people are used to a Apple or Google Maps outdoor wayfinding experience. So it's a very similar use case to that, but indoors. And then you can also use it for location analytics, dwell time analytics, path flow analytics through facilities such as shopping malls and all those sorts of good things too. So lots of different use case, but location discussions usually need to start with that question around what's the use case.
Yes, and we've got actually a demo ready to show you again after this as well, but we've got a couple of poll questions we wanted to ask you. First of all being, are you or your users happy with the current performance of your Wi-Fi deployment? So it's either yes, no, or maybe somewhat happy. So when you go into your place of work, your environment, are you able to seamlessly connect, stay connected, able to do all of your business applications and get through the day without having any issues with your Wi-Fi network? So it'd be very interesting. Yeah. Interesting to see.
And guys, before we share the survey results, let me just add the location. So I used to be a location geek, like a very nerdy about the location services, and Mist just works. Okay, it works. And when done properly with wayfinding, with a blue dot with your smartphone, we had less than half a meter error in a perfectly designed environment. We will show you how to do that shortly in a demo. But it really works. It's fantastic, and it's free. When you buy Mist APs, internal, external, doesn't matter. You will have those arrays in like a mid-range and high-end APs. Fantastic.
Yeah. So the good news is it seems that most people are happy with their current Wi-Fi deployment, or maybe they thought that their boss might be watching this webinar, so they better say yes in case they saw the results. So interesting to see those results there. And we have one final poll question before the next demo. So let me just quickly.
Ooh, that's a good question.
Yeah, let me just launch this one. So we would really love to know how often you're upgrading your Wi-Fi infrastructure. Are you doing it every 2 to 3 years, every 4 to 5 years, every 5 to 7 years, or do you only do it when it's necessary? So when the devices either go end of life or they come out of support. So this will be interesting to know. I'm sure, yeah, Rob and Stephen, you'll like the results of this one as well.
Again,
I'd be actually
results.
really curious to see the 5 to 7, what vertical they're in.
So 5 to 7, whoever has voted 5 to 7, what vertical are you in, guys? By vertical, we mean like a hospitality or the healthcare, education?
Automotive. Oh, interesting.
Okay.
Typically, what I've seen is it sort of comes back to what Rob was talking about earlier, and the cost benefit equation. So if it's office-based Wi-Fi, I'm not saying it's necessarily cheaper, but it is an easier environment to replace and redesign, and less costly than, say, replacing warehouse designs with external antennas every 3 to 5 years. So yeah.
Or in healthcare, like try to access all the areas, all the rooms. It's very, very complicated, isn't it?
Yeah, 24/7 operations, critical environments, it's very difficult to make changes, let alone upgrades or replacing infrastructure.
Yeah, so close to 60% updates the infrastructure between 4 and 7 years. That's the vast majority.
Not bad.
Cool. All right, Mac. Well, let's jump into the final demo for the webinar today. I know people are very excited to see this one.
Okay, let's do it. So I have a different project prepared for you, so we don't have to draw walls and waste time.
It's like I've seen this
done.
floor plan before. This must be a very famous building somewhere.
It is. It is. It's like half fake as well. So we photoshopped a lot of it. Okay, so now, boys, we have a floor plan. It is scaled. I can prove it to you. We have a scale here. It is scaled properly, and we have areas where we say this is like an office area, everything, and then inside the office area we have auditorium area that has higher density of the devices. So these are the important talking points. So Rob, Steve, what do I do?
Well, so generally I like to start in the most high density areas, the hardest areas. The nice thing about this floor plan is you actually chose something that isn't just a typical well, let me rephrase it. Some people would just typically blanket this with omnis and call it a day. But if you start to look at it, it's almost like, what I'm going to tell you to put there. You have different types of environments. So this goes back to kind of that similar with the warehouse, where you have different areas and where you need to do that. Let's bring the power down on that 5 gigahertz for me, please. Yeah. Is that the right antenna?
That's the 8 to 10 dBi gain antenna.
7. Go down.
You want a different one?
Yeah.
You want a different one? Okay. Which one would you prefer, sir?
It would be the Give me the 710, please.
710.
I think that was the right
Ceiling
one.
mounted, five
Ceiling
meters above the ground, and lowering the power level. But guys, look at the EIRP. So power level is 8 dBm, but EIRP is like 14, 15 dBm. That means that we have passive gain quite high on that antenna.
Yeah. So as you can see, if you just select that one of those antennas, as you can see, and if you change that direction, so where it goes more of a vertical, there you go. And now as you can see how you're getting that coverage. So this is that auditorium where you have that primary coverage. So, and this would come down to, again, a conversation with your customer on, do I need 2x2 redundancy? Is this going to be a high use area? I've done some customers where the auditorium is a no technology zone. So you just basically are more focused on making sure the connectivity is up towards the front, and the back, they are actually asking for you not to have technology there. So you could come to a point where we start looking at what's the expectation of the room, to where if it's just general coverage, we'd probably get away with 2 APs. If this is a developer room where they're going to be uploading code and doing all kinds of things, I'd probably move to 4 in there to have coverage. And then probably lower the power. I might even go look and try to see if I get a smaller beam width on the antenna, but this one would be a very good from a 2x2 coverage sense. Because again, if you just select one of those APs, so we could just see the pattern on one, it kind of sits there and holds in the area that you want and goes away. So, and then we can play a little bit and we can lower the power a little bit there. Again, 2.4 would definitely be 3 dBm, which is the lowest we can go in the system. But yeah, and in some cases, I might even turn off some 2.4 in there. But yeah, so we'd start here because this area is a primary high use area. I want this to be done right. And this goes also to see how it's going to affect other areas.
Just a quick addition there, guys, like never use that low powers with internal omnidirectional antennas with low passive gain, okay? We always want to try to match the transmitting power capabilities of the clients that we use in that environment.
So in this instance, as I'm designing, I would use the lowest power that's going to be in my RF template. So generally my basic RF template for an Omni would be 3 to 5 dBm in 2.4, and then 8 to about 12 or 14 in 5 gigahertz. Giving yourself a 3 dB separation between your 2.4 and 5. Again, we don't have time, but that's another soapbox. And then from there, now that I've got this auditorium design, then I'd start using my Omnis and start working around where the people are. So as you can see, Matt's over there putting it in the conference rooms where we are. And then,
You 6 gigahertz, Mac. The people in the chat want to see 6 gigahertz.
There we go.
Give the people what they want.
We're looking at 6 gigahertz now.
The green is much greener in 6 gigahertz.
It is indeed.
But yeah, so as you're seeing, you're peppering it. I usually, I'm in Europe and I still haven't gotten the meters to feet. I usually look at like 30 to 40 feet separation between APs. Because again, you're still, as you're using Omnis, that signal goes a good distance. You want to make sure that you are using it, but you're not being excessive. I'm a big fan of use the APs you need, not
You know, we have a feature, Mac, that can show you the distances between APs, right? It's under
Never heard of
action.
it.
Oh, there we go.
Hey,
Yeah.
Matt, it's Mac's first time using Ekahau. Just be gentle.
You're already on the paternity leave mindset, aren't you, Mac?
Yeah, totally, man.
So the
Okay.
interesting thing here now is we've got a great Wi-Fi design, and one of the slides we had earlier is that if you've got great Wi-Fi coverage from your access points, there's also likelihood to be Bluetooth coverage coming from the APs as well. So Mac, is there a way that we can see that with Ekahau?
Totally. I'm just like sorting out the transition areas. So I'm just like thinking for 802.11k to work like between that area and that area. So I'm trying to place these access points more strategically,
look at
so they're not in the
that.
middle of the corridor, but they can hear each other with a decent RSSI. So when your client moves from here and goes down this corridor, they will always jump between these 2 APs. Okay, they will never drop off. So yeah, that's a good design tip. Alrighty, so Matthew has asked about the BLE. So now we're looking at the coverage from on 6 gigahertz from the Wi-Fi perspective. 5 gigahertz is also awesome. 2.4, no one cares. Okay, so let's go to the BLE visualization, BLE Bluetooth coverage, and yeah, what are we
Before
looking
you
at?
pop over there real quick, I want to say one last thing on Wi-Fi design. As you see here, we excluded certain areas as part of design philosophy, especially because we're doing complex designs. Don't forget to ask if they actually want Wi-Fi in the bathroom or in the fire escapes, because more and more now I am seeing people say, yes, I need full coverage in bathrooms. Now, you're going to find very interesting things because a lot of times they don't want the APs in the bathroom because blinky lights seem to freak people out. But again, like fire escapes, like I'm a big fan. If you're going into a fire escape, I do the cardinal sin of mount it vertically because you have to
Like a
core
clock
and drag
on the
cable
wall.
on the wall. Because you have to drag, and you're using reflection then. You're using the reflection of the staircase to basically get you some extra distance. So you use less APs than if you were to mount them horizontally.
Yep. So you would basically place an access point on the wall, probably somewhere here, and configure it to be placed not on the ceiling like a default AP, but on the wall instead. So now it covers the staircase up and down very nicely.
Yeah. So you're basically taking that donut shape and you're turning it this way. So it's actually being designed to go the way that we usually don't want it to go.
Exactly. Okay, talk us through the BLE.
All right, so now you're looking through BLE. So somebody asked about use cases. So BLE has a lot of interesting use cases, but those are generally things that you need to design for beforehand and understand what you're doing. So the two main would be wayfinding, so blue dot, providing a map so people can walk around and know where they're at, or asset tracking asset tracking is usually the most used, especially during COVID. Nowadays, people have BLE tags on their badges. And so they want to use that for like occupancy and things like that. From this design, if you go ahead and scroll back out. So as he was saying, as Matt was saying earlier about the Bluetooth and the possibility of you having Bluetooth already built in and going is nice, but never, ever, ever take your Wi-Fi design and compromise it for the BLE. BLE, we have things that you can actually add. Every vendor has beacons. They have a way to add additional Bluetooth if you need it, or BLE if you need it. You don't ever, sometimes people kind of lose sight of saying, crap, I need to do a blue dot design, so I need to pepper this place with APs. And turns out you just made your Wi-Fi crap to try to get a Bluetooth design in. So that's little segue of warning there. But so as here, generally right now, if you do a high density design, you like Steven said, you're going to get 1 to 3 meter accuracy with asset tracking, which is generally nice because then you don't really have to do much of anything. Blue dot is a little bit different because there's a lot of magic that goes into it from the back end, where you're defining paths and you're defining where people are allowed to go. Because with Bluetooth, since it's a pulse technology, you kind of hop a little bit. So you want to give that smooth experience. You need to actually kind of give some boundaries and do a little bit more work behind there. And so you might need to do some additional BT11s, that's the missed version of a Bluetooth only AP to kind of give you additional coverage. But generally with mapping and stuff behind it, you won't need to add too many more.
So now with this design, we are looking at not like 1 to 3 meters accuracy. Now you're looking at 1 meter realistically with a blue dot design. Like honestly, not even kidding, that good.
That's really insightful to see, and some great tips there from Rob and Stephen about, supplementing your Wi-Fi design with those Bluetooth beacons so you don't go crazy and create lots of excessive co-channel interference. So that was really cool to see. I think, Mac, we've got a few other slides we just wanted to cover. I know we've gone a couple minutes over now, so maybe we can hop back to there quickly. And yeah, Rob, I think you were going to tell us about how much of a nightmare this can be, right?
I'm going to speed through it so that way we don't waste the time. Essentially, deploying something without thinking about it in advance can be very nasty and very manual. So starting from a floor plan, bringing it in, not using anything, you've got to go find the location, add it. You've got to review your list of inventory. You've got to scan everything in. Like I like the guy in the conveyor belt there because you never have the conveyor belt. You always have to play hunt and find. All the way down to now you're managing, trying to match those APs, those serial numbers with vendors and mounting. It's painful. Let's just look at the process. It's an 11-step process to do it manual. So there might be a few better ways to do it.
It sort of goes back to what I was saying earlier when Rob was giving the 5 steps to your design about knowing the platform, knowing the infrastructure, knowing the system that you're deploying with. And some of the questions I've seen have come up about in the chat is about, positioning APs from your design versus deployment, tweaking those, adjusting them. Most vendors have ways of doing this in an automated way, but it's how it works in your requirements for your deployment, for your environment, and how you're managing this as a project too. It needs to factor into your design and how that process actually feeds into the platform that you're designing with, or the infrastructure that you're designing with.
So yeah, this little GIF here is showing basically the ability to import your survey project and build and create a dashboard with the APs, serial numbers, and a lovely picture, which many people don't think is important. But can I share a picture? Can I share my screen for a second? I have.
Yeah, of course.
As we go ahead and talk about design, we've talked about design, yeah, what happens when your lovely brand new design, your installer does that?
Yikes.
So it's one of those things where you need having all of these little tools and things, just as simple as a picture coming in and going, I could have the greatest design in the world, but the guys mounting the APs like that doesn't mean anything.
How did you get a picture of one of Mac's deployments?
And I think
it was it's his first day with Ekahau. He didn't know that the ceiling tile was there.
Ah, that was it. So as we kind of wrap up the content of the webinar today, we just want to remind you again, you can come and join us on September 19th for the Wi-Fi Day. We've got a great lineup, lots of amazing content and lots of cool things to go over with you. So please make sure you sign up. Thank you so much, Rob and Stephen, for taking time out of your day. I know it's late for you guys and you're extremely busy. Clearly, everybody really loved the content. I personally found it really fascinating. Some of the tips you guys get from these experts and their knowledge is just fantastic. So a huge thank you personally from me and everyone else that's joined the webinar today. I know people have loved it. So thank you so much, everybody, for joining us. And yeah, we'll look forward to seeing you at the next one.